Question 1. If the function f of x is equal to cos x raised to 1 by x, where x is not equal to 0 and k x is equal to 0 is continuous at x is equal to 0, then the value of k is, we're given 4 options. Take limit x approaches to 0 cos x raised to 1 by x, which is equal to k. Taking log on both the side, we get limit x approaches to 0 1 by x log cos x equal to log k. We take limit on both the things. We take limit x approaches to 0 1 by x, limit x approaches to 0 log cos x equal to log k. For the solving, we can write limit x approaches to 0 1 by x into 0 equal to log k, where we get k equal to 1, which is our option A. Therefore, option A is the correct answer. Question 2. If f of x is equal to sine bracket x upon x plus 1 for x is greater than 0, cos pi by 2 x upon x for x less than 0, where x k at x is equal to 0 denotes the greatest integers less than or equal to x, then in order that f be the continuous at x is equal to 0, then the value of k is. If f is a continuous at x is equal to 0, then limit x approaches to 0 from the left hand side of fx is equal to limit x approaches to 0 from the right hand side of fx equal to f of 0. So limit f of 0 equal to limit x approaches to 0 from the left hand side of fx will be k equal to limit h approaches to 0 f0 minus h equal to limit h approaches to 0 cos pi by 2 0 minus h upon 0 minus h. Solving further, we can write k equal to limit h approaches to 0 cos pi by 2 bracket minus h upon minus h. For the solving, we get limit h approaches to 0 cos pi by 2 minus h minus 1 upon minus h minus 1. Further solving this, we can write k equal to limit of h approaches to 0 cos minus pi by 2 upon minus 1, which is, if we solve, we get k equal to 0, which is our answer matches with option A. Therefore, option A is the correct answer. Question 3. If f of x is equal to x square minus 10x plus 25 upon x square minus 7x plus 10 for x is not equal to 5 and f is a continuous at x is equal to 5, then the function f of 5 is equal to, we're given 4 options. F of 5 equal to limit of x approaches to 5 f of x. Therefore, substituting the value of f of x, we get limit x approaches to 5 x square minus 10x plus 25 upon x square minus 7x plus 10. Solving the numerator, we get limit x approaches to 5, where we can write numerator as x minus 5 the whole square upon x minus 2 x minus 5. Further, we can write this as 5 minus 5 upon 5 minus 2. is equal to, we get as 0. Therefore, option A is the correct answer. Question 4. In order that the function f of x is equal to x plus 1 raised to cot x is continuous at x is equal to 0, f of 0 must be defined as, we are given 4 options. For continuity at x is equal to 0, we must have f of 0 equal to limit of x tends to 0 f of x. Substituting the value of f of x, we get limit x approaches to 0 x plus 1 raised to cot x. We multiply and divide by 1 by x in the indices, we get limit x approaches to 0 1 plus x 1 by x x cot x. Therefore, we can write cot x as 1 by tan x, limit x approaches to 0 1 plus x upon raised to 1 by x, limit x approaches to 0 x raised to tan x. Therefore, we can write this as e raised to 1 equal to, we can write this as e, which is equal to e. The whole limit changes to e raised to 1, which is our answer e. Therefore, option C is the correct answer. Question 5. If f of x is equal to 1 minus sin x upon pi minus 2x, which is x is not equal to pi by 2, lambda x is equal to pi by 2, be continuous at x is equal to pi by 2, then the value of lambda is, f of x is continuous at x is equal to pi by 2, then f of pi by 2 equal to limit of x approaches to pi by 2 f of x. We can substitute the value, the function of f of x, that is and f of pi by 2, we know it is equal to lambda, so therefore lambda is equal to limit x approaches to pi by 2 1 minus sin x upon pi minus 2x, which is in the form of 0 by 0, where we can apply L'Hospital's rule. From L'Hospital's rule, we get lambda is equal to limit x approaches to pi by 2, where we get 1 minus sin x can be written as minus cos x upon 2 minus 2. Therefore, lambda is equal to limit x approaches to pi by 2 cos x 2, where we get r is equal to 0. Therefore, our answer matches with option C. Therefore, option C is the correct answer. Question 6. If f of x is equal to 2 minus root x plus 4 upon sin 2x, where x is not equal to 0, as continuous function at x is equal to 0, then the f of 0 equals, we are given 4 options. If f of x is continuous at x is equal to 0, then f of 0 equal to limit of x approaches to 0, f of x should be equal to limit x approaches to 0, 2 minus root x plus 4 upon sin 2x, which is in the form of 0, 0, 0 upon 0. So we can apply L'Hospital's rule. We can write f of 0 equal to limit x approaches to 0 minus 1 by 2 root x plus 4 upon 2 cos 2x. For the solving, we get minus 1 by 8, which is our answer matches with option D. Therefore, D is the correct answer. Question 7. The function defined by f of x is equal to x square plus e raised to 1 by 2 minus x raised to minus 1, where x is not equal to 2 is continuous and k x is equal to 2. For right at the point x is equal to 2, then k is equal to f of x equal to x square plus e raised to 1 by 2 minus x raised to minus 1, and f of 2 is equal to k. F of x is continuous from right at x is equal to 2, then limit x approaches to 2 from the right, f of x is equal to f of 2 equal to k. Therefore, limit x approaches to 2 from the right, x square plus e raised to 1 upon 2 minus x raised to minus 1 equal to k. We get k is equal to limit h approaches to 0, f of 2 plus of h. Therefore, we get k equal to limit h approaches to 0, 2 plus h the whole square plus e raised to 2 minus 2 plus of h. We get raised to minus 1. For the solving, we get k equal to limit h approaches to 0, 4 plus h square plus of 4h plus of e raised to 1 by h minus 1 raised to minus 1. Further, we get 4 plus 0 plus 0 plus e raised to infinity minus 1 raised to minus 1. Therefore, we get this as k equal to 1 by 4, which is our answer matches with option B. Therefore, option B is the correct answer. Question 8. The function f of x is equal to 1 minus sin x plus cos x upon 1 plus sin x plus cos x is not defined at x is equal to pi. The value of f of pi so that the f of x is continuous at x is equal to pi is given. We have given 4 options. We have f of x is equal to, we can write this function as 2 cos square x by 2 minus 2 sin x by 2 cos x by 2 upon 2 cos square x by 2 plus 2 sin x by 2 cos x by 2, which can further written as cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2. Therefore, this can be written as tan pi by 4 minus x by 2 at x is equal to pi. Therefore, we get f of pi minus tan pi by 4, which is equal to minus 1, which is our answer matches with option C. Therefore, option C is the correct answer. Question 9. If f of x is equal to 1 minus cos x upon x, where x is not equal to 0, and k, where x is equal to 0, is continuous at x is equal to 0, then k is equal to, we have given 4 options. Limit x approaches to 0 from the right hand side of fx should be equal to f of 0. So therefore, we can substitute the value of f of x, where we get limit x approaches to 0, 2 sine square x by 2 upon x, which is equal to k. Here we can write this as limit x approaches to 0, 2 sine square x by 2 upon x by 2 the whole square into x by 4, which is equal to k. Therefore, for the solving, we get k equal to 0, which is our option A. Therefore, option A is the correct answer. Question 10. The function f is defined by f of x is equal to 2x minus 1. If x is greater than 2, f of x is equal to k. If x is equal to 2 and x square minus 1, if x is less than 2. is continuous, then the value of k is equal to, we give 4 options. We have f of x is equal to 2x minus 1 if x is greater than 2. Then we get f of x is equal to k. If x is equal to 2 and x square minus 1 if x is less than 2. Function is continuous. So therefore, limit x approaches to 2, f of x is equal to f of 2. Therefore, we can write this as limit x approaches to 2, 2x minus of 1 equal to k, where we get k is equal to 3. Therefore, answer matches with option B. Therefore, option B is the correct answer. Question 11. The value of f at x is equal to 0, so that the function fx is equal to 2 raised to x minus 2 raised to minus x upon x, where x is not equal to 0, is continuous at x is equal to 0. As we're given 4 options over here. We have f of 0 equal to limit x approaches to 0, f of x equal to limit x approaches to 0, 2 raised to x minus 2 raised to minus x upon x, which is in the form of 0 by 0 form, where we can write limit x approaches to 0, 2 raised to x plus of 2 raised to minus x log to the base e to 2 upon 1. Further solving this, we get 2 raised to 0 plus 2 raised to 0 log to the base e 2. Therefore, 1 plus 1 log to the base e 2. We get 2 log to the base e 2, which is equal to log to the base e 4. With this, we see our answer matches with option D. Therefore, D is the correct answer. Question 12. If f of x is equal to log to the base 1 minus 3x, 1 plus 3x, where x is not equal to 0, and for k, x is equal to 0, is continuous at x is equal to 0, then the value of k is, we know that the function is continuous as at x is equal to 0. Therefore, f of 0 equal to limit x approaches to 0, f of x. We can substitute f of 0 as k equal to limit x approaches to 0 log to the base 1 minus 3x 1 plus 3x, where we can write this as limit x approaches to 0 log 1 plus 3x upon log 1 minus 3x. Further, we can multiply. We divide and multiply by 3x in the numerator and the denominator. We get limit x approaches to 0 log of 1 plus 3x upon 3x into 3 upon limit x approaches to 0 log 1 minus 3x upon minus 3x into minus 3, which we get this as k equal to minus 1, which is our answer matches with option A. Therefore, option A is the correct answer. Question 13. If f of x equal to e raised to kx minus 1 the whole square sin x upon x cube, where x is not equal to 0, and for 4 x is equal to 0 is continuous at x is equal to 0, then k equal to, we give 4 options. Function is continuous, so we can write this as f of 0 equal to limit of x approaches to 0 f of x, where we can write f of 0 as 4 equal to limit x approaches to 0 e raised to kx minus 1 the whole square sin x upon x cube. We multiply and divide by kx square on the right hand side, that is 4 equal to limit x approaches to 0 kx square into e raised to kx minus 1 the whole square upon k square into x square into sin x upon x, where we get 4 equal to k square. The limit of the whole function we get as 1, so we get k 4, where we get k square is equal to 4, which can be written as k is equal to plus minus 2, which our answer matches with option C. Therefore option C is the correct answer. Question 14, for the function f of x, x cube minus a cube upon x minus a, where x is not equal to a and b, x is equal to a. If f of x is continuous at x is equal to a, then b is equal to, we're given 4 options. So function is continuous at x is equal to a, so we can write this as f of a equal to limit of x approaches to a of fx, where we can write b equal to limit x approaches to a x cube minus a cube upon x minus a. Therefore we get b equal to limit x approaches to a x minus a x square plus xa into a square upon x minus a, where we can write this as b equal to a square plus a square plus a square. Therefore we get as 3a square, which is equal to b. Therefore our answer matches with option C. Therefore C is the correct answer. Question 15, the value of p and q for which the function of f of x is equal to sin p plus 1 x plus sin x upon x, where x is less than 0, and for q x is equal to 0, root x plus x square minus root x upon x cube by x raised to 3 by 2 for x is greater than 0 is continuous for all x and r. Here we have q is equal to limit x approaches to 0 from the left hand side of fx, which can be written as limit x approaches to 0 sin p plus 1 x plus sin x upon x, which can be written as q equal to limit x approaches to 0 p plus 1 into sin p plus 1 into x upon p plus 1 x plus sin x upon x, where we get as p plus 1 plus 1. Also for q equal to limit x approaches from the right hand side of fx, we can write this as limit x approaches to 0 from the right hand side, we get root x plus x square minus root x upon x raised to 3 by 2. We take this as equation 1. We can write this as limit x approaches to 0 root x 1 plus x minus 1 upon x root x. We can write this as equal to limit x approaches to 0 1 plus x raised to 1 by 2 minus 1 by x. We can further solve this as equal to, that is q equal to limit x approaches to 0 1 plus half of x plus continue to minus 1 by x, where we get q is equal to 1 by 2. Let this be 2. Therefore we solve for p from 1 and 2, that is equation, we get p plus 2 equal to 1 by 2, where we get p is equal to minus 3 by 2 and q is equal to 1 by 2. If we see, our answer matches with option C. Therefore option C is the correct answer. Question 16. If f of x is equal to 20 raised to x plus 3 raised to x minus x raised to x minus 10 raised to x upon 1 plus cos 8x for x is not equal to 0, k by 16 log 10 by 3 into log 2 for x is equal to 0 is continuous at x is equal to 0, then the value of k is. So the function is continuous at x is equal to 0. We can write this as f of 0 equal to limit of x approaches to 0, 20 raised to x plus 3 raised to x minus x raised to x minus 10 raised to x upon 1 minus cos 8x. Further, we substitute the function at f of 0. We can write this as k by 16 log 10 by 3 into log 2, which is equal to limit x approaches to 0, 10 raised to x minus 3 raised to x, 2 raised to x minus 1 upon, we can write this as 1 minus cos 8x as 2 sine square 4x. Further, we can write this as limit x approaches to 0, 10 raised to x minus 1 upon x minus of 3 raised to x minus 1 by x into 2 raised to x minus 1 by x, 2 into sine square 4x upon 16x into 16. Further, we can solve this as log 10 minus log 3 into log 2 upon 32, where we can write this as k upon 16 log 10 by 3 into log 2, which is equal to 1 by 32 log 10 by 3 log 2. Therefore, we can write this as k is equal to 16. We see that k by 16 log 10 by 3 log 2 equal to 1 by 32 log 10 by 3 into log 2. Further solving this, we get k by 16 equal to 1 by 32. Further, we can write this as k equal to 3 log to the base 3 1 by 2, where we use the formula a raised to log to the base a x equal to x. If you see which our option answer matches with option B, therefore B is the correct answer. Question 17. If f of x is equal to 1 minus root sin x pi minus 4x, where x is not equal to pi by 4, for a x is equal to pi by 4 is continuous at x is equal to pi by 4, then a is equal to, so function f of x is continuous at x is equal to pi by 4, so we get f of pi by 4 equal to limit x approaches to pi by 4 f of x, where we can write pi by 4 f of pi by 4 as equal to a, limit x approaches to pi by 4 for f of x we can write as minus root x, 1 minus root 2 sin x upon pi minus 4x. Further applying L'Hospital's rule for on the RHS side, we get a equal to limit x approaches to pi by 4 minus root 2 cos x upon minus 4. Further solving, we get a equal to 1 by 4, which is our answer matches with option D. Therefore, option D is the correct answer. Question 18. Let f of x is equal to tan x minus cot x upon pi, where x is not equal to pi by 4 and x minus pi by 4. For a is equal to x is equal to pi by 4, the value of a, so that the function is continuous at x is equal to pi by 4. Therefore, we see f of x is continuous at x is equal to pi by 4. So we take f of pi by 4 equal to limit x approaches to pi by 4 f of x. Further, we can write this as a equal to limit x approaches to pi by 4 tan x minus cot x upon x minus pi by 4. Applying L'Hospital's rule on the right hand side, we get a equal to limit x approaches to pi by 4 sec square x plus cos x square x upon 1, where we get a equal to root 2 the whole square plus root 2 the whole square, which is equal to 4. So our answer, that is a equal to 4, matches with option B. Therefore option B is the correct answer. Question 19. Let f where r approaches to r be defined by f of x is equal to cos 3x minus cos x upon x square for x not equal to 0 and for lambda x is equal to 0. If f is continuous at x is equal to 0, then lambda is equal to, since f of x is continuous at x is equal to 0, we get f of 0 equal to limit x approaches to 0 f of x. So we can write f of 0 as lambda equal to limit x approaches to 0 as cos 3x minus cos x upon x square. So applying L'Hospital's rule on RHS side, we get lambda equal to limit x approaches to 0 minus 3 sine 3x plus sine x upon 2x. Same, we apply L'Hospital's rule on the right hand side, we get lambda equal to limit x approaches to 0 minus 9 cos 3x plus cos x upon 2, where we get lambda equal to minus 9 plus 1 by 2, where we get as minus 4 as answer. So therefore option B is the correct answer. Question 20. If f of x is equal to 1 minus sin x upon pi minus 2x the whole square when x is not equal to pi by 2 and f of pi by 2 is equal to lambda, then f of x will be continuous function at x is equal to pi by 2 when lambda is equal to, we are given 4 options. Since f of x is continuous at x is equal to pi by 2, so we can write this as f of pi by 2 equal to limit x approaches to pi by 2 f of x, where we get as lambda equal to limit x approaches to pi by 2 1 minus sin x upon pi minus 2x the whole square. Applying L'Hospital's rule on the right hand side, we get lambda equal to limit x approaches to pi by 2 minus cos x upon minus 4 pi minus 2x. Same, we apply L'Hospital's rule on the right hand side, we get lambda equal to limit x approaches to pi by 2 sin x upon minus 4 minus 2, which we get as lambda is equal to 1 by 8, which is our answer matches with option A. Therefore option A is the correct answer. Question 21. The function f where r belongs to 0 tends to r given by f of x 1 by x minus 2 e raised to 2x minus 1 can be made continuous at x is equal to 0 by defining f of 0 as, we given 4 options. F of x is continuous at x is equal to 0, we get f of 0 equal to limit x approaches to 0 f of x, where we can write this as limit x approaches to 0 1 by x minus 2 upon e raised to 2x minus 1. We can write this as limit x approaches to 0 e raised to 2x minus 2x upon x into e raised to 2x minus 1. Applying L'Hospital's rule on the right hand side, we get f of 0 equal to limit x approaches to 0 2 into e raised to 2x minus 2 upon x 2 into e raised to 2x plus 1 e raised to 2x minus 1. Further, applying L'Hospital's on the right hand side we get f of 0 equal to limit x approaches to 0 4 into e raised to 2x upon 2x into e raised to 2 into e raised to 2x plus e raised to 2x into 2 plus of 2 into e raised to 2x. For the solving we get f of 0 equal to 4 plus 2 plus 2. We get f of 0 equal to 1, which is our answer matches with option B. Therefore option B is the correct answer. Question 22. The value of f of 0 so that the function f of x is equal to root 1 plus x minus 1 plus x raised to 1 by 3 upon x becomes continuous is equal to, again 4 options. Limit x approaches to 0 f of x equal to limit x approaches to 0 1 plus x raised to 1 by 2 minus of 1 plus x raised to 1 by 3 upon x. Further we can write this as limit x approaches to 0 1 plus 1 by 2 into x minus 1 by 8 x square plus continue minus 1 plus 1 by 3 into x minus 1 by 9 x square plus, we can write this as x on x. Further we can write this as limit x approaches to 0 1 by 2 minus 1 by 3 into x plus 1 by 9 minus 1 by 8 x square plus continue upon x. For the solving we can write this as limit x approaches to 0 1 by 2 minus 1 by 3 plus 1 by 9 minus 1 by 8 into x plus, therefore further we get f of 0 is equal to 1 by 6. If f of x is continuous at x is equal to 0, therefore f of 0 we get as 1 by 6, which is our option A. Therefore option A is the correct answer. Question 23. If f of x is equal to log to the base e 1 plus cos x square into tan x upon sin x cube, where x is not equal to 0 is continuous at x is equal to 0, then the f of 0 must be defined as, since the function f of x is continuous at x is equal to 0, so we can write this as f of 0 equal to limit x approaches to 0 of f of x. So therefore we substitute the value that the function f of x as log to the base e 1 plus x square tan x upon sin x cube. Therefore solving this we get limit x approaches to 0 log to the base e 1 plus x square tan x upon x square tan x into x square tan x upon sin x cube. For the solving we can write limit x approaches to 0 log to the base e 1 plus x square tan x upon x square tan x into x cube upon sin x cube into tan x upon x. So we solve for this, and the limit we can substitute x as 0, so we get f of 0 equal to 1, which is our answer matches with option A. Therefore option A is the correct answer. Question 24. If f of x is equal to x square minus 4x plus 3 upon x square minus 1 for x is not equal to 1 and 2 for x is equal to 1, then we are given 4 options. F of x, let limit x approaches to 1 f of x equal to limit x approaches to 1 x square minus 4x plus 3 upon x square minus 1 equal to limit, which can be written as x approaches to 1 x minus 3 upon x plus 1 equal to minus 1. Therefore we have f of 1 equal to 2. Therefore f of 1 is not equal to limit x approaches to 1 f of x. Hence the function is discontinuous at x is equal to 1. So we see that option C, that is the function f of x is discontinuous at x is equal to 1, is the correct answer. Question 25th. For the function f of x is equal to e raised to 1 by x minus 1 upon e raised to 1 by x plus 1, where x is not equal to 0 and 0 for x is equal to 0, which of the following is correct? We are given 4 options. Limit x approaches to 0 from the left hand side of fx, we get equal to limit h approaches to 0 e raised to minus 1 by h minus 1 by e raised to minus 1 by h plus 1 equal to limit h approaches to 0 1 by e raised to 1 by h minus 1 upon 1 plus e raised to 1 upon e raised to h, which is equal to, we can write 0 minus 1 upon 0 plus 1, which is equal to minus 1. Further solving for right hand side, that is limit x approaches to 0 from the right hand side of fx, we can write this as limit h approaches to 0 e raised to 1 by h minus 1 upon e raised to 1 by h plus 1. For the solving, we can write this as limit h approaches to 0 minus 1 upon 1 upon e raised to 1 by h upon 1 plus 1 upon e raised to 1 by h. Further, we can write this as 1 minus 0 upon 1 plus 0, which is equal to 1. Therefore, we see left hand side and the right hand side, that is L of limit of x approaches to 0 from the left hand side, that is minus, we see that limit x approaches to 0 from the left hand side of fx is equal to limit x approaches to 0 from the right hand side of x. So limit f of x exists at x is equal to 0, but at x is equal to 0 is not a continuous. So if we see, we got limit x approaches to 0 from the left hand side is equal to minus 1, and from the right hand side we got 1. So therefore at x is equal to 0, it is not continuous. Therefore our option, we see D, that is limit x approaches 0 f of x exists, but f of x is not continuous at x is equal to 0. Therefore option D is the correct answer. Question 26. The function f of x is equal to mod of x upon x square plus 2x, where x is not equal to 0 and f of 0 is equal to 0 is not continuous at x is equal to 0, because we are given 4 options. For limit x approaches to 0 from left hand side of fx equal to limit x approaches to 0 from the left hand side mod x upon x square plus of 2x. So we can write this as limit x approaches to 0 minus x upon x square plus 2x equal to minus of, same as limit x approaches to 0. So limit x approaches to 0 from the right hand side of fx equal to limit x approaches to 0 from the right hand side, we get mod x upon x square plus of 2x. We can write this as x upon x square plus 2x. So there is a limit x approaches to 0, we get half. So limit f of x does not exist. Therefore we see the limit we get for right hand side we get half, and from the left hand side we get minus half. So limit f of x does not exist. Therefore D is the correct answer. Question 27. The value of a and b such that the function f of x is equal to minus 2x minus 2 sin x, where x is less than equal to minus pi by 2, a sin x plus b, that is x greater than minus pi by 2 less than pi by 2 is, or cos x, x greater than equal to pi by 2, continuous everywhere R, we give him options for A and B, that is the value of A and B. So for continuity at all x belongs to R, we must have f of minus pi by 2 equal to limit x approaches to pi by 2 from the left hand side minus 2 sine x. Further solving this, we get limit x approaches to pi by 2 from the right hand side also, that is as a sine x plus b, which we get 2 equal to minus a plus b, with let b this as equation 1. So for f pi by 2, we get limit x approaches to pi by 2 from the left hand side as a sine x plus b, which we get as limit x approaches to pi by 2 from the right hand side as cos x. For the solving, we get 0a plus b. Let this be equation 2. So solving 1 and 2, we get a equal to minus 1 and b equal to 1, which is, if we see option or answer matches with option C, that is a is equal to minus 1 and b is equal to 1. Therefore option C is the correct answer. Question 28, let f of x is equal to 1 minus tan x upon 4x minus pi, where x is not equal to pi by 4. Continuous in 0 comma pi by 2, then f of pi by 4 is, we are given 4 options. So f of x is continuous in 0 comma pi by 2, so it is continuous at x is equal to pi by 4. So therefore f of pi by 4 equal to limit x approaches to pi by 4, f of x equal to limit x approaches to pi by 4, 1 minus tan x upon 4x minus pi. Applying L'Hospital's rule on the right hand side, we get f of pi by 4 equal to limit x approaches to pi by 4 minus sec square x upon 4. Therefore we get f of pi by 4 equal to minus 2 by 4, which is equal to minus half. Therefore we see our answer matches with option C. Therefore C is the correct answer. Question 29, for every integer n, let a n and b n be the real numbers. Let function f, where r belongs to R, be given by f of x a of n plus sine pi by x for x belongs to 2n and 2n plus 1, bn plus cos pi x for x belongs to 2n minus 1 comma 2n. For all integers n, if f is continuous, then which of the following does not hold for all n? We are given 4 options. Since f is continuous at every point in R, f is continuous at x is equal to 2n. So limit x belongs, that is approaches to 2n from the left hand side of fx is equal to limit x approaches to 2n from the right hand side of fx, which is equal to f of 2n. Further, we can substitute the value of function f of x. We get limit x approaches to 2n from the left hand side bn plus cos pi x equal to limit x approaches to 2n from the right hand side of an plus sine pi x. For the solving, we get bn plus of cos 2n pi equal to an plus sine 2n pi. Therefore we write this as bn plus of 1 equal to an. So we get an minus of bn equal to 1. So option C, if we see option C, we get as correct answer as an minus bn equal to 1. Also f is continuous at x is equal to 2n plus 1. Therefore solving for this, we get limit x belongs to 2n plus 1 from the left hand side of fx equal to limit x belongs to right hand side of fx equal to f of 2n plus 1. Further, we substitute the function as limit x approaches to 2n plus 1 from the left hand side a of n plus sine pi x equal to limit x to n plus 1 from the right hand side of bn plus 1 plus of cos pi x. Further solving this, we get as an plus of sine 2n plus 1 pi equal to bn plus 1 plus cos 2n plus 1 pi. Further solving, we get an is equal to bn plus 1 minus of 1. Therefore, we get as an minus of bn plus 1 equal to minus 1. Replacing n by n minus 1, we get an minus 1 minus of bn equal to minus 1. So if we see, option A and D are correct for this. So hence the option D does not hold. So we get A, C and D as correct. So the following question was, then which of the following does not hold for all n? So we say that option B does not hold. So therefore option B is a correct answer. Question 30. The value of a and b such that the function defined by f of x, that is 7ax plus b, for 7 it is f x is less than 2 for ax plus b, for x greater than 2 less than 9 is continuous, and for 2 if x is greater than equal to 9. Function we are given 4 options. For limit x approaches to 2 from the left hand side of fx is equal to 7, and limit x approaches to 2 from the right hand side of fx is equal to ax plus b equal to 2a plus b. Since f of x is continuous at x is equal to 2, we can write this as, therefore limit x approaches to 2 from the right hand side is equal to limit x approaches to 2 from the left hand side. Therefore we get as 2a plus b equal to 7. Let this be equation 1. Also limit x approaches to 9 from the left hand side, for fx we get as 9a plus b, and limit x approaches to 9 from the right hand side, we get f of x is equal to 21. So therefore we see that this both are equal to each other, so we get 9a plus b is equal to 21. Let this be equation 2. Solving 1 and 2, we get a equal to 2 and b equal to 3, which is our answer matches with option B. Therefore option B is a correct answer.